class and you want to do research assistant work for an economist in the future, let me know and I can arrange that.
I'm thinking, I was talking about last night.
So today we are entering sort of the final stretch of the course. So far we did perfectly competitive models, then we did monopoly models. Today we're going to do models where there are more than one but still a small number of firms. So that will be a bridge between monopoly and competition. And the basic problem is, the monopolist has an optimal thing to do. Competition, everyone takes prices as given, so everyone has an optimal thing to do. But there's lots of different ways one can think about how people interact oligopolistically or strategically. And that's what makes oligopolistic interactions a bit more complicated than either monopoly or competition. So today we're going to look at a range of different ways of thinking about oligopoly. So we'll start with sort of the most classical model, which is Cournot's model of quantity choice. We'll then look at the so-called Bertrand-Edgeworth critique of the Cournot quantity choice model, and we'll talk about both the paradox of two firms and then heterogeneity of various sorts as solutions to this problem. We'll then talk about collusion and the incentives that firms have to collude, how it can be difficult to collude in situations where collusion will be easier. We'll then talk about conjectural variations models as ways of nesting collusion into a model of competition. And we'll talk about how to empirically measure conjectures. Okay, so let's start with the most classic model of oligopoly, the Cournot model. So Steve, can you tell me what goes on in the Cournot model? What's the basic idea? Don't read off the slides.
Not sure. I didn't get a chance to get to that reading.
Okay. Anybody else want to describe the Cournot model? Yeah, Mike.
The first firm takes the quantity to sell, and the next firm follows.
No, that's the Stackelberg model. Who else wants to describe the Cournot model? Okay, nobody else. Okay, so there are n firms, and they produce a homogeneous product. That is, they're all producing the same thing. And we'll often assume, including during most of the class today, that they have a constant marginal cost C. And each firm is going to take as given the quantity produced by other firms. So they're going to choose the optimal quantity to produce or the optimal price to set, taking as given the quantity produced by the other firms. So this is quite similar to the sort of competition that we talked about in Lecture 9, remember? In Lecture 9 I talked about the possibility that someone else would come in and produce a bit of the good that you're producing, right? And sometimes this is referred to as firms choosing quantities, but this is a little bit misleading. It's really that firms take as given the quantities of other firms. And we'll talk about this more in a bit. So equilibrium is then when each firm maximizes its profits given the quantities produced by the other firms. And they sort of all do that at the same time. That's an equilibrium. So each firm is going to earn profits, which is the quantity they sell, times the price, which depends on the quantity they sell, QI, and the quantity sold by all the other firms. Capital Q sub negative I. Negative I indicates everyone except for firm I. Times minus the cost. And Emily? Hey! Let me give you a moment to collect yourself. But then, so we're talking about the Cournot model. And this is the firm's profits, the amount that they produce, QI, times the price, which depends on their quantity, and the sum of everybody else's quantities. Can you tell me what the marginal revenue is in this case?
Marginal revenue would be good price takers?
No, they're taking as given the quantities of all the other firms.
Taking a given quantity. So it would be.
So his revenue is QI times P, right? So what happens if you take the derivative of that with respect to QI?
QI, oh, it's P of QI.
Yeah.
That is QI P prime,
Yeah?
of just QI, I guess, because
Well, if QI plus,
QI plus
yeah.
to QI. Minus QI, or not, minus C. Plus, QI prime plus P QI plus PQI.
Yeah, it's P plus P prime times QI, right? So, yeah, so it's just this here. And capital Q here is the total quantity that everyone's producing, including me. So marginal revenue, the key point here is that marginal revenue is going to be closer to demand than with monopoly. Why? Because QI is smaller than Q. If there are other people producing, right, then the amount that I care about my inframarginal units that I'm producing is less than the amount that the industry as a whole cares about. Raising the price. So this means that the markup's going to reduce. And in particular, imagine that all the firms produce the same amount. They're all the same. So then QI is equal to capital Q over N, which is going to now give us a new version of Lerner's rule. David, what's that going to be? What's Lerner's rule going to become here? The elasticity pricing rule. Remember how we got Lerner's rule? We got it by transforming this P prime thing, right? And now that whole term is going to be divided by N. So what is that going to do to Lerner's rule? Okay. Well, it's going to give us that the markup over price is equal to, it used to be equal to 1 over the elasticity, right? And we derived that from this P prime term, right? If that's now divided by 1 over N, then we just divide this term that includes that by 1 over N, and we get the exact same result, right? So the markup is going to be equal to 1 over N times the elasticity rather than 1 over the elasticity. So as the number of firms gets large, the markup is going to get small, and that's going to be something we'll focus on. Okay, so notice a few things. First of all, even when there are lots of firms, even if we had 10 firms, there would still be a significant markup. Now, it would be like as if there was 10 times the elasticity, but it still wouldn't be infinite, right? So we'll explore on Tuesday the fact that this gradually is going to go to 0. It's gradually going to go to infinity as n gets large. That's not going to be the focus today. Our focus today is going to be on how the oligopoly works, and then on Tuesday we'll talk about what happens to the oligopoly as there are more firms. Second, notice that the prices are in between those of a monopoly and perfect competition, right? Perfect competition would be if this is infinity. Monopoly would be if this is 1 over the elasticity, and this is going to be somewhere in between those two, right? And one of the most interesting results coming out of the Cournot Model arises only when firms are asymmetric, which we're not going to go through and mathematically solve today. We will actually. Okay, so it comes when firms are asymmetric. So imagine that different firms have different costs CI, right? So then each firm is going to set their marginal revenue equal to their individual marginal costs, right? And that means that lower cost firms have to be producing more, right? Because in order to have to set their marginal revenue equal to a lower marginal cost, because they all have the same marginal revenue function, right? They have to be producing more, right? But them producing more is going to mean that they're charging a higher markup, right? But the problem is that the high-cost firms are still going to be producing some, right? Unless their cost is so high that that they go above the top of the marginal revenue curve, they're still going to be producing some, right? And that's really inefficient, right? Because ideally, all of the goods should be produced by the low-cost firm, right? It's wasteful for some of them to be produced by the high-cost firm. So what that shows is that under monopoly, a firm would always choose to minimize costs, right? Because that's how it maximizes profits. Under competition, we know that everything is efficient, so everything is produced in the most efficient way. But under oligopoly, it can often be the case that there's what's called productive inefficiency. Even given what's produced in the market, it's not produced in the most efficient way. And we can now add this equation up across all the firms in the industry, just sum over I, and we get that Q times P prime of Q plus N times P of Q is equal to the sum of all the firm's costs. Another way we can say that the average cost is if we divide this by N, and then we get that the average quantity times P prime plus P is equal to the average cost. And so what this says is that if any of the firm's cost increases, that leads to 1 over n of the pass-through that would happen for a monopolist. And the reason is that if one firm's cost increases, that increases the average cost by 1 over n times that, right? Because there are n firms. So the point here, which is going to be crucial, is that it's only the average cost that matters, right? This industry acts as if we're sort of like a monopolist, or monopolist with a little bit higher elasticity that just had the average cost of the firm. So the heterogeneity among firms, the fact that some firms are more efficient than others, doesn't end up mattering all that much for the prediction of the model, right? It only cares about the average cost. And in some sense, this makes the model much more robust to heterogeneity among firms than the other models we're going to look at in a minute, and that'll be a key point of contrast that we're going to make. Okay, so let's take a step back and ask what was the process that we went through to solve this model, right? So we said that the firms took as given some action taken by the other firms, right? Why would they do that? Well, that was just the assumption we made. And more generically, in economics, we call something a strategy if I take as given your choice of that thing. So I treat your quantity as your strategy if I take as given the quantity that you choose. And we assume that each firm optimized given the fact that it took this as given. So this is more generally called a Nash Equilibrium. So when we talk about Nash Equilibrium, that means that everyone optimizes taking as given the strategy, whatever that is, of other firms. So this seems sort of like a relatively simple and reasonable notion of equilibrium, but the devil is all in the details of what we take as given, right? Because we assume that firms believe that other firms' quantities stayed fixed. But why should it be their quantity that stays fixed? Why couldn't it be their price or their markup or anything else, right? And this is the basic problem that arises in any strategic model you think of. Anytime there's a small number of people, not one who's optimizing, not a big market, but a small number of people, everything is going to depend on what each person takes as given that the other person does. And oligopoly is just one example of this problem. So we'll focus on oligopoly because it's one of the most important ones, but this shows up in many contexts. Anytime you hear people talking about game theory, these are the problems that they're